Can you see my screen?
Yes.
Okay, let me start the student discussion session. The first topic is about the model ship materials. As you know, most of the model ship are made up of wood and some other pieces. So most of the ships are made of wood or wax and paraffin or plastics or some lightweight metals and special type of papers. So as you can find from this, most of this model ship does not make up of steel. But as you know, the real ship is made up of mild steel or some strengthened steel. So the question is, why model ships are made up of wood, not the steel? And the second one is, if it is made with the wood, what a disadvantage can be possibly happens for the model ships? Let me know your idea.
Okay, I have an opinion.
Yep.
Well, thin metal is hard to make a model ship because thin plate is hard to weld, and mechanical connection is hard to make waterproof. So make a model ship with thin metal is very hard to make. Hard to make. Yeah. Loading problem and connection problem.
Okay, thank you. Is there any other idea?
Yeah, I have a opinion.
Okay.
I think the steel model is to low buoyancy because the model must be made very small, and it expected the sufficient buoyancy will not occur if the model is made small with high density metal.
So you mean not enough buoyancy to float the model, the steel model?
Yes.
Thank you.
I have a point. One reason can be wood is easy to use and it's cheap.
Yep. Okay. Most of the points are set. I just want one last opinion from another one.
I think wood is relatively hard and it's also a durable substance.
Can you speak a little bit louder? I cannot hear.
And durable substance.
Durable? So you mean the wood is durable?
Yeah.
Uh,
So we feel like it has some issues with like strength, but when it says like in terms of durability, it's relatively good as a model.
okay, I see. So most of you guys have pointed why the model ships are made up with the wood. So as the Singyu said, the thin metal is hard to build, so wood is quite easy to fabrication, not fabrication, but building. So it's just like as Gupta says, and Donggun says the steel is quite heavy and the model ship is quite small. So the model ship, if we made a model ship with a steel, it cannot, maybe it cannot float on the water because the volume is quite small than the real ship. So Donggun has a point, and Gavin says wood is a durable substance. Yeah, but it can be a controversial because wood can be rot or harmed by some other environmental causes. So yeah, from these reasons, most of the model ship uses the wood. And is there any possible disadvantages of the wooden ships? Just let me know your opinion freely.
Maybe for the disadvantage, the skin of wood and steel will not be the same, so there might be error from there.
So you mean basically the two materials are different, so the simulation can be different, you mean?
Yes.
Yeah, thank you.
Yeah, I have two opinion. Wood, I think wood has low strength compared to metal, so I think it need the additional structure for the increase the strength. And second idea is wood will undergo deformation and corrosion by water. So the result using the wood are change over the time. Yeah.
Okay. So yeah, the wood is quite soft material rather than steel. So maybe these problems can be happen with the wooden model ship. Okay, let me continue to next topic. The second topic is about the hull resistance. So this graph is about the overall hull resistance from some paper. As you see, as the ship speed increases, the total resistance also increases, like this line. And as Muhammad presented, the total hull resistance can be consisted of like this: the friction resistance and wave making resistance. So the wave making resistance can be treated as the residual resistance. And lastly, the air resistance can be one of the part. So I found this graphs with the same papers. So the top line is the same line from the previous slide, and the other lines are expressing the portions of the friction resistance and residual resistance and the air resistance. So this is quite a simple and easy quiz. So there is total 7 different blocks, and the options are 3. So I want to hear your answers about this.
I think number 1 is air resistance.
Okay, can I hear why you think like that?
Because according to the lectures and other sources, it's the smallest portion that contributes to the total resistance.
Okay, thank you. You must look at the ship speed and the resistance relationship.
I think number 3 is frictional resistant, because as we learned the student lecture, the friction resistance increase linearly with the speed by fluid number. So it seems to be the frictional resistance.
Okay, thank you.
And number 2 is the wave making resistance.
Yeah, so I will express as the residual.
Because, well, the low speed, it's more, the viscous resistance is like stronger, but for the high speed, like the wave, the residual resistance becomes much more important.
Yeah, exactly. So as the speed increases at a specific point, the stress, the resistance increasingly very dramatically. So this is a residual. So can you feel the last 4 blocks? Basically, these graphs are from the different source, so quite looks different, but the overall algorithm or something. Anyway, similar graph, so maybe you can express it. But for the right image, the air resistance are skipped.
So from that, I think 6 will be residual
Yep.
and 7 is frictional.
Okay, so if 6 is a residual, 7 would be frictional, naturally. And the last is number 4 and 5. The ratio between the residual resistance and frictional resistance. The x-axis is same like the speed, so maybe you can find it very easily. Okay, nobody wants to answer. So number 4 is the residual, so sorry, frictional. Because with the slow speed, the frictional resistance is the major resistance from the ship, and as the speed increases, the residual resistance portion increases as the speed increases. So this is the answer. Okay. The final one is a little discussion about the external causes of these resistance types. So just let me know your idea. What external causes can determine the resistance value? Maybe it can be some surface roughness or wind power or something. Just let me know freely.
I think the frictional resistance is determined by the external viscosity of the liquid.
Yep.
If it's water or some other liquid, it could be different. And the surface roughness might also be important.
Thank you.
And frictional resistance include total ship length, because the fluid number is include the length term.
So ship length, you mean?
Yeah.
Okay, thank you. This can be a major problem, major cause of the friction resistance. Okay, we have 2 ideas from the frictional, so let's skip to residual. What is important for the wave making resistance? What things influence to this resistance?
Well, I think velocity it connected to another.
Okay. Oh, you finished? Oh. I couldn't hear you.
I finished. I said the opinion. Let me think.
Okay, okay, I see, I see. Maybe I'll give you one. The tidal height, the wave height, I mean. Wave height. Oh. And wavelengths can be external causes of the residual resistance. Because the residual resistance is basically related to the wave making and eddy current resistance. So this can be one external causes. Okay, I'll just want the last one from anybody.
Like factors that contribute to viscous pressure. So, yeah, viscous pressure, like, yeah, either ways.
Viscous pressure. Yeah. I'm not sure about the viscous pressure means, but maybe the pressure can be one reason. I see. So, yep. This residual resistance is related to weight. So maybe you can think it after the class. So these are my references, and thank you for listening.